Yesterday we have studied about force, types of forces, and a lot about force. Now today we will start about a topic, pressure. Pressure is defined as force per unit area. The SI unit of pressure is Newton per meter square or Pascal. Other units of pressure are Newton per centimeter square or Newton per millimeter square. They are used when areas are small, but these are not SI units. Formula for pressure is equal to force upon area. This is the page of your book. You see here there's a apple. It is cut by a knife. The knife is sharp, so it is easy to cut. But if the knife is blunt, then it is difficult to cut. Here you see a knife. This is the sharp edge of the knife. So you see, if the edge is sharp, it is easy to cut. But if it is blunt this side, it's not possible to cut from this side, but it is possible to cut from this side because that is sharp edge. Similarly, you see a needle here. This is a needle. The tip of the needle is very fine, so it is very difficult, very sharp. So area is very less. So the pressure applied on the finger is very more. So area is less, the pressure is more. So sharp edges, it's easy to cut an object. A pressure depends on two factors. The first is force and second is area. Force is more, then the pressure is more. That means force is directly proportional to the pressure. More the force, more the pressure. The pressure is directly proportional to force, or force is directly proportional to pressure. Both mean the same thing. So pressure is directly proportional to force, and area is more, the pressure is less. Area is more, the pressure is less. That means pressure is inversely proportional to area. Greater force means greater pressure, greater area means lesser pressure. Here you see this example, two types of shoes are being shown here. One is type A, another is type B. One having broader area, another having pencil heel. So the area is more in case of A, area of the shoe is less in case of B. So the pressure is less in case A and more in case B, because case A area is more, the pressure is less, case B area is less, the pressure is more. You see, what is same in both the cases? The force applied, that means the person who is wearing these shoes is same. What is different in both the cases? In case A, the force is applied on a bigger area. In case B, force is applied on a smaller area. So, in case A, area is more, the pressure is less. Case B, area is less, the pressure is more. The same force The same force produces less pressure if it acts on a larger area, but can produce more pressure if it acts on a smaller area. A person, you see here, there's a diagram here, and in this you see a person, and when a person is poked with a finger, then the area of the tip of the finger is more, the pressure is less. When the area is more, the pressure is less. Second case, the person is poked with a syringe, and the syringe, that is a needle, so it's pointed. The area is less, so it's easy to poke into the person's body when with the help of the needle. So needle, it can easily pierce into the person's body, but the finger will not pierce into the person's body. Difference between force and pressure. Force is a push or a pull on an object, and pressure is the ratio of the intensity of force and area on which it acts. Both have got direction. Force is having direction and pressure is also having direction, but force has got a unique direction. Pressure can be applied in different directions also. Example, in case of liquid pressure, when force is applied, it spreads in all the directions. And now daily observations, the first example here, the school bag, and this is school bag here, you see it has got wide straps. So when the straps are wide, it's on your on the pressure applied on your shoulders is less, area is more, so the pressure will be less. And whereas if the straps are narrow, then the pressure is more, so there will be plenty of pressure on your shoulders and it will be difficult for you to lift the bags. Sharp knife, edges of the knife, when it is sharp, then it is very easy to cut. But when it is the but when it is not sharp, it is blunt, then it is difficult to cut. Similarly, you see tractors have broader tires. The tires of tractors are very broad in order to increase the area, because the tractors are heavy, and so if the area is more, so the pressure has to be less. You see here, this in this it is easier to walk, it's easier to walk on soft sand if we use flat shoes, because the area is more, so the pressure will be less. And when the shoes are have got sharp heels, then it is easier, it's very difficult to move on the sandy or muddy areas or regions. The foundations of buildings and dams, when they are laid, they are quite broader, because the area is more, so the pressure will be less. Similarly, the wooden or concrete sleepers that are applied below the railway lines, the steel railway line, below that you see uh, there are sleepers which are applied, and these sleepers, they are quite broader in area, so area is more, so the pressure of the train can easily fall on them, and the pressure will be less, and the train can easily pass over these railway lines. Similarly, you see the broad belts are provided over the wheels of army tanks. The tank is very heavy, it is made of steel, and so when the area is broader, the pressure is less. Here, this is an example here, relationship between force and pressure. So force is more, the pressure is more. The force is more, the pressure is more. When force is less, the pressure is less. The envelope of air that surrounds Earth is called air, and this air has got a lot of pressure. This is called as atmospheric pressure. So this air, here you see, this is an example where air is filled into the bicycle, and with the help of a pump. When the pump is pulled and then pushed, then the air pressure is increased, and that goes into the bicycle, and the air goes into the bicycle. So by this way, you see, air has also got a lot of pressure. So the pressure of air is spread in different directions, in all the directions. That it doesn't mean that only one direction the pressure is applied. The pressure is applied in all the directions. That is, when it goes into the tire, it spreads in all the directions. So the air pressure spreads in all the directions. Similarly, liquid pressure also exerts in all the directions. Thank you.